glass, children, in the second glass, the sand particles slowly settle down because they are heavy and under the influence of the gravity, they were pulled down. If you leave them undisturbed like that, all the particles will slowly settle down. But can you see the milk particles settling down, children? No, the particle size is comparatively less, so they be suspended like that throughout the mixture, but they won't settle down. That is the main difference between suspensions and colloids. So they settle down. These particles, they settle down, whereas colloids, they don't settle down. They don't settle down because the particle size is very light and very small, so they are comparatively lighter. They will be simply dispersed throughout the mixture, but they won't settle down. So because they are settling down, they can be separated by some physical methods like filtration. You can filter off sand from water. But can you filter off milk particles from water? It is very, very difficult. We cannot do that. So here we cannot separate using, here we can separate. Here we can separate, right? We can separate through filtration. But here we cannot separate through filtration. Right, children? The other one, very important phenomenon you have to learn now is the scattering of light. Is the scattering of light. It is called as Tyndall effect. It is called as Tyndall effect, named after the scientist who discovered it. So we'll be learning about this Tyndall effect now. So let's learn about the Tyndall effect now. Tyndall effect is a phenomenon of scattering of a beam of light by the particles of the mixture. Like if you take sand and water mixture, or if you take milk and water mixture, they both have the tendency to scatter the beam of light. Usually this effect can be seen naturally also. If you just say, take for example an empty room, and through the ventilator, when the light beam enters that room, you can see that the dust particles, because of the dust particles, the beam of light is visible. Can you see? Have you seen any time, children? In a dark room, especially when the sun rays enter that room through ventilator holes or anything, then you can see that beam of light rays just because of the dust particles which are present in the air. So the dust particles are dispersed in the air, which try to scatter the beam of light because they come in the way of light, in the path of light, then they will be just scattering the beam of light. So then the light beam is visible, right? So that scattering of beam of light by the particles of a medium is called as Tyndall effect. To understand this scattering of light better, let's do another small activity. So we have already seen those mixtures of salt and water, sand and water, and milk and water, right? Let's pass through a beam of light ray through those mixtures and see through which glass or beaker we can see the light visible. Okay, we can see the light beam. So let us do that activity and see for ourselves. So when a beam of light is passed through salt solution, you cannot see any path visible through the solution, right? See? But the same beam, when it is passed through sand solution, you can easily see its path, a boundary, a clear boundary is visible through the solution. So that is called as Tyndall effect. Now the same beam, when it is passed through milk also, you can see the path visible through the solution of milk. Can you see that, children? Very clearly you can see the beam of light through the solution, right? You see, children, in the first glass where we dissolved salt and water, the particle size was so small that they did not scatter the light beam at all. So we could not see the beam of light through the solution, right? But in case of the sand and water and milk mixture, we could easily see the beam of light through the solution. We could easily find